Welcome to your AI college. Today we will discuss about an AI agent memory. Let's assume you're speaking to one chatbot application. Let's say you say, my name is Gopal Modi and I am a learner, and it responded with, "Hello Gopal Modi, nice to meet you." Now if I ask him what is my name, then it just simply do not know, right? So it's not remembering our any previous conversation. Now, wait a minute. Didn't we solve the similar problem when we discussed about multi-turn conversation concept in our episode 2? Yes, we did solve it. And that was the simplest form of short-term memory giving to our agent. We solved it by keeping the global message list, and this global message list keeping all the previous conversation happen to our agent. And whenever a user is giving a new prompt, new question, we are attaching all the previous history and giving it to the LLM. And that's how it was able to answer the user question. See here, we are keeping this message list and we are taking the user prompt, we are appending into the message, then we are calling to the agent, and whatever agent is responding, that also we are appending. Okay. And now if this while loop comes again, and again if user gives some new prompt, then all the previous prompt it already has. So now LLM is having all the previous history also, plus plus the new message also, and that's how it's able to answer. And as I mentioned, this is a very simple form of a short-term memory giving to our agent. Let's ask ourselves a few questions like how we'll handle the growing message list. So if you see here, we are keeping the global message list and which will going to grow on every single prompt. How will going to handle this? What happen when we have a multiple user? So in this example, only one user is interacting with our agent and our messages list is keeping the context for that user only. How are we going to handle if there are multiple user wants to interact with our agent? Obviously, we do not want one user interaction or one user context influence the another user conversation. Third, what if our agent get crashed? And for that, we're going to implement the persistent storage. So to solve all this, we have to do this, right? Reduce the message list. How? We'll see in this episode. Maintain the history at per user level. How? We'll see in this episode. And persistent storage. That also we're going to look at into in this episode. Now all this can be implemented manually, but it would require a lot of efforts, boilerplate code, etc. For this exercise, let's build all this with a LangChain. Now, before we go for hands-on, let's just get ourselves familiar with these terms. Short-term memory versus long-term memory, thread, state, and checkpointer. Let's just start with the short-term memory and long-term memory. Short-term memory is like remember the things within the conversation, and long-term memory means remember the things across the conversation. Let's just see a very quick example. So let's just write my name is Gopal Modi and I am a learner. Okay. And let me ask now, what's my name? What's my name? So it remember my name, right? I have given my name here and remember. So it's remember the things within the conversation. So this we called as a short-term memory. Okay. And let me open another conversation, or we can call it like another thread. And let me just ask him, what's my name? See, this is a new thread, but it remember my name. So it remember the thing across a conversation or across a thread. And this is what the long-term memory is. Now let's just understand thread. So thread is not a Java thread. In a LangChain, the thread is a logical group of conversation. Example, here we just created a two thread, right? So we can create a one more thread like this. And we can say, hi, how are you? So this new thread is got created. And this is what the thread it is in the LangChain. Now the state. State is nothing but the current status or current situation of an agent, like while he's doing the job. what it has done, what it is doing, and what it is waiting for. Check pointer. Check pointer is a mechanism that helps to store this state into the memory and help to retrieve that state from the memory. And that memory could be either in memory or either it could be a persistent storage. Let us start the hands-on now. For that, first let's just replace this manual in memory to the LangChain in memory. So we'll just write, like, we'll just define one checkpointer. It could be any variable name, but let's just say checkpointer equals to in memory saver. Right now we are going with the in memory, and then later we'll replace it to the persistent storage. Okay. So we have defined our in memory. Okay. And this in checkpointer we have to give to the agent. We'll say checkpointer equals to this. Okay. So checkpointer. Okay, we are given. Now we don't have to append this. We don't have to append anything. Okay. We don't have to do this also. What we can do, we'll define like this, and we'll just say human message, human message. Okay. And context equals to user prompt. Okay, that's it. Now let's just give a run. We'll say hi. Oh, it failed. And it failed with a very obvious reason. We just studied that checkpointer help us to store the state into the memory. Okay, and state is like what agent is doing currently, what it has been waiting for, right? And that agent will have multiple threads. So that state will keep an information of a thread also. Like for that thread, what is its current state, right? So here, if you see, we did not even provide it that this conversation or this message, this prompt belongs to the which thread, right? So for that we have to just give this information. Okay, hey, we will tell to the agent, okay, hey, this the prompt which user is giving is belong to this particular thread. So we just give this we just define this configurable thread id, and we'll just give the some unique thread id, right? And we'll just give this config to the our to our agent. Okay, here we go. Okay, now let's just give a run. Okay, now we'll say hi. My name is Gopal and I am a learner. Okay, it responded with hello Gopal. Now I'll just ask what's my name. Okay, so it remembered my name. So our agent is keeping and storing the all the states, and this is how we build the short-term memory. Now wait a minute. We still didn't solve the problem of a long conversation history. Earlier, we were keeping the manual message list, and now we are using the LangChain managed memory. But the problem remains the same. It is still going to pile up all the conversation. Let's just solve this now. So to reduce the message list, we have a four common patterns: trim messages, delete messages, summarize messages, or custom strategy. Trim message is like asking just to keep the last end message and remove the remaining one. Delete message is like deleting the whole history, whole message list. Summarize is like instead of this whole message list, we can give this message list to another LLM, ask it to summarize it, and whatever the summary that we are getting, that we can store into the history, and remaining all messages, previous messages, will delete it. Custom strategy is like giving your own filtering logic, and whatever message got filtered, those only you will going to delete. So here you can define your own logic to reduce the message list. Let's implement the trim message pattern, and we will just going to keep last 5 messages and rest will trim it down. And for that, let's just define a function which LangChain going to call internally. So we'll say def and we'll say trim underscore messages. Okay, it will accept the state, which is kind type of agent state. Okay, which is type of agent state, and it also accept the runtime. Okay, and it will going to return the dictionary dictionary of string or any, or either it could return the none. Like if the length of the message list is less than 5, then we don't have to trim it down, right? So that for that we'll return the none. Okay, now let's just take the messages from the state. Okay, so we have the state object. From there we are taking the messages, and now we are checking if length of these messages is greater than or equal to 5, then we don't have to trim or anything, so we'll just return the none. We'll just say return none. Okay, now if the message length is more than 5, then we have to trim it down, and for that let's define another variable called resend messages, and just take the last 5 messages from that list. Okay, now we cannot directly return this resend messages from this function, but we have to return in a way which tell to the LangChain, hey LangChain, delete all the previous messages and just add these recent messages. And for that, we will going to write a return statement like this. So we'll say return messages, remove all the messages and just add this recent messages. Okay. Now let's just resolve this. We say import. Okay. We'll also resolve this. We'll say import this. Say add. Okay, now we also have to import this, say remove messages. Now we have defined our trim message function. Let's just give this function to the agent, and agent will take like kind of a middleware. So we'll say middleware, and it can accept the multiple middleware. So we'll just give this array, and we'll just give this middleware here. Okay, so it can accept the multiple middleware, and those middleware can be called before the model or after the model. Here we are trimming it before the model. So we'll just say, we'll just annotate this function with the before model annotation, before model annotation. Okay, and let's just import this also. Okay, now we have pretty much, let's just give a run to it. Okay, we'll say my name is Gopal Modi and I am a learner. Okay, it responded with hello Gopal Modi. Now we'll say teach me AI in 10 words. Okay, it responded again. Now we'll say who is Sachin Tendulkar. Okay, it responded Sachin Tendulkar is a legendary Indian cricketer. Now we'll ask what's his DOB. Okay, so now there are like 1, 2, 3, 4, 5, 6, 7, 8. 8 messages are happened. Okay, now it already got trimmed, and now if I ask him what's my name, then it will not remember my name. So it responded, you didn't provided your name, but we have provided. So that got trimmed down, right? Now I'll just say my name is Gopal Modi. Now if I'm ask him again, what's my name? Okay, so it remember my name now. So all the previous history which are beyond the 5 messages, it getting discarded, it getting trimmed. Okay, and that's how we can implement the trimmed message middleware. Now let's implement a summary pattern where we will give all the message list to another LLM and ask LLM to summarize it, and whatever the summary that LLM will return will replace with the message list. Now there are two ways to implement a summary pattern. One, here only we can give this messages list to the another LLM with a prompt asking it to summarize it. Okay, and whatever the LLM is respond, the same summary will we can give here to our agent. That is a one way. Another way is to use built-in summarization middleware, which is given by the LangChain only. For this exercise, we're going to use that one only. So let's just build it. So let's just comment this out, this code. Okay. What we're gonna do, we'll just define a summary middleware. So we'll say summary underscore middleware equals to summarization middleware. Okay. And to it, we just have to give the model which is would be your LLM. So it could be any LLM. Okay. And then we say when it should get trigger. So we'll say you should trigger it when the tokens are 500. And if it is go beyond the 500, then you should trigger it. Okay. And we just have to tell one more thing. So we just also have to tell the keep, like how much, like how many minimum messages you should keep, right? So minimum messages are like, I'll say messages. Okay. And I'll just say at least keep the 5 messages. Okay. So yeah, I guess this is how we can define the middleware, and the same middleware we just have to give here summary middleware. Okay, I guess that's it. Let's just give a run. Okay, I think we made a small mistake. Okay, sorry, yeah. We don't have to give this. Okay, we just have to give this. Okay, let's just give a run now. Okay, I say my name is Gopal and I am a learner. Okay, so it responded. Now we can ask another question like teach me AI in 10 words. Okay, and now we'll ask who is Sachin Tendulkar. Okay, what's his DOB? Okay, it responded Sachin Tendulkar was born on the November 24th, 1970. Now I'll just ask him, what's my name? And it will remember my name. For yes, see why it remember my name? Because we are asking to summarize it. Like if it is beyond the 500, so keep the 5 message. But if it is, but if the token is beyond the 500, summarize also. So now we have implemented trim message middleware and summarize message middleware. And you can implement the delete messages in the same way like we implemented the trim message, and you can define your own strategy also. And these patterns helping us to reduce the context that we send to the LLM. And it's very much important as every LLM has a finite context limit. We cannot always send the whole message history. Now let's solve the next problem. What happens when we have a multiple users? To show the multiple user interaction, let's just simplify our code. Let's remove this while loop and create a multiple user prompt. So we can just simply say this, and instead of taking the input, we'll just directly put the prompt here. My name is, I'll say my name is Gopal and I am a learner. Okay. And we'll just give this config. So I'll say config1. Okay. Response, and then we'll just print the response. We'll just say config1 here. Right. Now the similar way, I can define the second user prompt. So I'll say user underscore prompt 2. I'll say config 2. Okay. And the same way, I just have to give the prompt to here, and config 2 will come here. Okay. And we have to now here I can say who is Sachin Tendulkar. Who is Sachin Tendulkar? Okay. Now we have given the prompt, we have given the config. Now here to maintain the two thread or to maintain the two user, we have to give a different thread ID. If we do not give a two different thread ID, then both the conversation will belongs to the one thread only. And hence, so we have to give the another thread ID here like this. Now we can print it here, right? Now let's just give a run to it and then we'll continue. Okay, for the first AI responded this, and for second, let's see what it going to respond. Okay, for second, it responded about the Sachin Tendulkar, right? Now let's just do one thing. What we can do, we'll copy paste this and we'll just give config1 only, but ask what's my name. Okay, what's my name, and instead of this thread id 1, so this conversation is belonging to the thread 1, but now let's just give the thread 2 here. Okay, Now let's see what it's going to answer. Okay, so first it responded hello Gopal Modi. Okay. Second, it will tell about the Sachin Tendulkar. And third, it will try to find what's my name. But then if we look into the previous history, which is belong to this thread too, there it will not find my name, and hence it will not be able to answer me. Let's just see. Okay, so it told about the Sachin Tendulkar. Now now it again responded. Your name is inserted your name here, right? So it don't know my name. Okay. Now what we can do, we'll just do this and give the thread one only. Okay. Now the last message which going to print by this should have my name. Okay. So first, okay, let me explain you again. So we have given this prompt and AI responded this. Okay. Now the next prompt is running, which who is Sachin Tendulkar, and it's running on another thread. Okay. It responded about the Sachin. Okay. Now we asked what's my name on thread 2. Okay. So it don't know the name, right? Since you did not provided your name in the previous message. Okay. Now we change it to the thread 1, and it knows my name. And this is how it's keeping the history at per user per thread level. Now let's solve third problem. What if our agent get crashed and we lost the history? So for that, we just have to give the persistent storage. And let's just give a three simple change. Okay, first we have to install the PostgreSQL, okay, in local. And instead of the checkpointer in memory, we just have to give the Postgres server.from connection string. And then we have to apply the checkpointer.setup. So this will create all the necessary tables in the Postgres. And full working example with a persistent storage we'll see later in this series. And I hope by now you have understood what is memory, what is a short-term memory, long-term memory, and how we can reduce the context giving to the LLM, and how multi-user context is being handled, and how we can add the persistent storage to our agent. If you like our video, please hit a like and subscribe for more. Your AI College.